Okay, here we go. We're going to do introduction to water balance. So, what is water balance? So, water balance basically is that the water itself is not hungry for minerals or not looking to plate minerals out onto any surfaces. So, as an example of that, Sydney Water wants to make sure that the water that's going through their pipes is reasonably balanced, so it doesn't just eat away at the pipes and create huge problems. Same thing for your pool. You don't want to have unbalanced water getting in, causing concrete cancer or plating out stains on the walls. So water balance is the relationship between temperature, pH, water hardness, and alkalinity. It's got nothing to do with chlorine levels, stabilizer, salt, anything else that's in the pool. It's purely these. The biggest effect on water balance is pH. Definitely the biggest effect is pH. And water hardness and alkalinity are very similar, and temperature you don't have a lot of control of, and it has the least effect on the balance of the water. Basically with a pool, as an example, you can have, say you can have a pH very low, very acidic, say a pH of 4, but the water can still be in balance. It still can not be corrosive, not be scale forming, because with a pH of 4 you can have very, very high hardness. So you might have 1,200 parts hardness, and you might also have very high alkalinity, say, and we'll keep the temperature constant, say 20. Because the pH is low, is offset by very high water hardness and very high alkalinity. But if you had a pH of 4 and you had normal levels of hardness and say normal levels of alkalinity here, and you had a pH of 4, then that water would be extremely corrosive. It would start to attack any of minerals in the pool. It would start to eat away at them very, very quickly, because it's hungry to get into balance, and it's trying to do that by increasing its water hardness level. It's trying to get that up because it's just looking for those minerals. So on the other hand, if we took this same scenario here, 20 degrees, but we gave it a very high pH, say of 9.5, 1200, 300 alkalinity. You wouldn't want a pool like that or a pool like this, but you increase the pH, all of a sudden the pool is trying to get rid of this. It's trying to give away all of the minerals in that are dissolved inside, so in the water. So you might find that the water turns cloudy white, starts to put white deposits all over the pool, put white deposits all through the sand filter. We have come across pools in the past where the sand filters have been concreted up, basically, because it's just deposited everything in there. So basically that's an idea of what it is meant to be in water balance. It's whether the water is trying to get rid of these minerals. The water hardness is the minerals dissolved in there. It's trying to push them out and get them onto walls to get back into balance, or whether it's looking for them to try and get back into balance. Water will always try and find that balance. Now the key there is, with being a pool, really, what you're aiming at for effective sanitation is a pH of around about 7.5. So, get rid of all this. So with pools, obviously, you don't want to have a pH of 8, very acidic, or pH above 8.2 really, which becomes too basic. So you really want to have a pH of around 7.2 to 7.6. You want this here to have effective killing power in your chlorine. If you let the pH drift too high, then the chlorine that's in the water becomes ineffective at killing nasties. So when you're talking about water balance for a pool, you're looking at 7.2 to 7.6 to try and maintain that for as long as possible. This then means to have the water in balance, you're looking at the water hardness of around about 250 to at the most 350. And then your alkalinity is around 80 to 120. So that's where those recommended ranges come from, is not for any other reason than you want to have the pH sitting in that effective killing power range. So therefore, to keep the water close to being in balance, you've got to maintain your hardness levels at that range and then your alkalinity in those ranges. Sometimes we get asked questions about, alkalinity in particular. In a lot of manuals will say, 80 to 200 is okay. And it can be okay so long as if you're running at the high end of alkalinity, you want to be running at the low end or even lower of your water hardness to keep it in balance. But that is where, you're in that range there, you need to maintain those. The sticking point with pH is that in the 7s, it goes up and down very quickly. It doesn't take a lot of aeration or a lot of material to go in there to take it from 7.2 even up to 8. So that's why we recommend that little weekly dose of acid done by the customer to continually knock it down. It'll drift up into the 8.0 within a few days, and we want to get them to knock it on the head and bring it back down to 7.2, and then it'll drift up for the next week and knock it back, drift up, knock it back. If that's in 3 weeks space, if the customer does nothing, you have your 8 mark here, and 3 days after our service it's back up to 8. If they do nothing, then it's continuing up to 8.2 to 8.4, and at 8.5 is that magic 3% of the chlorine is effective, which is nothing. Pretty much at 8.5, none of the chlorine in the pool is doing anything. So very important that we get this message through to our customers, that they should be doing at least the little dose of acid each week in between our visits, or in between their water tests in the shop. Any questions?